Okay, so now I will show you different diagrams for water. Now we will see PV diagram, TS diagram, pH diagram, HS diagram for water, and these diagrams are very important in order to solve the questions very easily. Okay, and I told you some few examples in the I think unit 5 में हमने जो कुछ क्वेश्चन सॉल्व किए. With the help of this diagram you can see how easily we can do analysis. Okay, so the very first diagram is the TS diagram. This diagram we have already seen. सबसे पहले जो in the beginning of this unit I told you about this TS diagram only. Here I am showing the saturation curve as well. So you can see the saturation curve. Let's suppose this P1 is the atmospheric pressure, and initially I am having the ice at minus 10 degrees centigrade. Okay, just recall those things I just told you in the beginning of this unit. Okay, so initially as I am supplying heat, the entropy is increasing, the temperature is increasing up to, let's suppose, 0 degree centigrade, as we are considering atmospheric pressure. At 0 degree centigrade this ice will melt, temperature will remain constant, it will absorb latent heat of fusion, the temperature is constant. Up to 0 degree centigrade water, here at this particular point we are having 0 degree centigrade water. Now on further heating, further providing heat, entropy obviously will continuously increase as we are providing heat to it, and the temperature will also increase. This heat is known as the sensible heat, as we have discussed, sensible heat of liquid. Okay, so 0 degree centigrade water will convert to 100 degree centigrade water. Then after that 100 degree centigrade water will convert to 100 degree centigrade saturated steam. Okay, so this is the transition zone. Okay, and after that 100 degree centigrade saturation steam will be converted to up to suppose 200 degree centigrade superheated steam. Okay, so this we have discussed it for atmospheric pressure, and I told you one thing, if I am increasing the pressure, what will happen? This zone is decreasing, as you can see. Okay, this zone is continuously decreasing, that means latent heat is continuously decreasing, first thing. Second thing, the saturation temperature is increasing. As I am increasing the pressure, the saturation temperature, as you can see, is increased. Okay, so this here we are having, this is a solid line, this is a liquid line. Okay, here this is a saturated vapor line, this line you can see is the saturated vapor line. The phases here are solid, here the phase are solid plus liquid, only liquid, liquid plus vapor, and vapor. Okay, triple point is a line in this particular figure, in this TS diagram. Triple point, this whole line we are having it as a triple point. That means at this whole line water will exist in all three phases of solid, liquid, as well as in gas. Okay, and the pressure, temperature, and volume of this critical point, this point is a critical point where the zone of this, where this zone becomes 0, HFG becomes 0, latent heat becomes 0, that point is known as critical point. And at this particular point the pressure is 221.2 bar, temperature is 374.115 degree centigrade, and volume is, specific volume is 0.00317 meter cube per kg, and as we are moving upwards the pressure is increasing, that means P2 is greater than P1. Okay, this is already we have discussed. Okay, fine. Now next is again this TS diagram, and we will discuss different lines, different curves in this particular TS diagram. Okay, so as you can see I am just drawing this much zone, this zone. Okay, just remove this, I am just drawing this zone, and we will see how are the constant pressure lines, constant temperature lines, constant enthalpy lines, constant volume lines, and so on. So you can see here. Okay, so these are in purple, we are having constant pressure lines, and pressure is increasing as we are moving upwards, as I have already told you. That means P2 is greater than P1. Okay, these all things are very important. You can pause the video and you can draw the diagram, and with this diagram you can solve certain questions, the certain set of questions very easily. Getting this or not? Okay, now in green we are having constant enthalpy lines. You can see H1, S2, and S3. Okay, and this is increasing in this direction, the enthalpy is increasing in this direction. That means this H3 is greater than H2 is greater than H1. इस direction में जब हम जा रहे हैं, this enthalpy is continuously increasing. Okay, third thing, constant volume lines you can see in yellow. I don't know you can see or not because this is quite light. Okay, this is V1 and this is V2 and this is V3. In yellow you can see constant volume lines, but the volume in this direction, the volume is decreasing. Getting this? Volume is decreasing. That means V3 is less than V2 is less than V1. Okay, again I will tell you, P2 is greater than P1, pressure is increasing in this direction, ऊपर की तरफ जा रहे हैं, the pressure is increasing. Okay, the volume, as we are going upwards, the volume is decreasing and enthalpy in this direction is increasing. S3 is greater than S2 is greater than H1, V3 is less than V2 is less than V1. Clear or not? Okay, And one more thing, this is the constant dryness fraction line. In blue you can see at saturated vapor line obviously the dryness fraction is equal to 1. Okay, और जैसे जैसे हम कर्व के अंदर की तरफ आ रहे हैं the dryness fraction will decrease. Okay, so these are constant dryness fraction lines. Here x is equal to 0.9, here x is equal to 0.8 and so on. Okay, here at saturated liquid line obviously here x will be equal to, here x will be equal to 0. Okay, because here we are having pure liquid, the dryness fraction will be 0, and as it is increasing the value of x will increase. Let us suppose here the x is equal to 0.1 and so on. Okay, so this is the TS diagram, temperature entropy diagram for water. Getting this or not? Okay, next is the pH diagram, pressure enthalpy diagram, again very important diagram. So you can see the saturation curve here, this is the saturation curve in black, we are having the saturation curve. Okay, and as we are moving in this direction obviously the dryness fraction will increase. Okay, in this direction the dryness fraction will increase. Here at saturated liquid the dryness fraction x is equal to 0, then x is equal to 0.1, 0.2 and so on. Here x is equal to, you can see 0.9, and finally this x is equal to 1 at this particular point. Clear or not? This is the critical point. Critical point, we have already seen what is critical point. Okay, now coming to the constant pressure lines. So here you can see the constant pressure constant temperature lines. Okay, constant pressure line obviously will be horizontal throughout. Constant temperature lines you can see in green. Okay, and as we are moving in this direction, this temperature is increasing. Okay, that means T3 is greater than T2 is greater than T1. Clear or not? ऊपर की तरफ जा रहे हैं, obviously as pressure is increasing the temperature will also increase. Okay, first thing. Now here in this blue color you can see constant entropy line S1, S2 and S3, and in this direction, okay, this whatever I am telling you in this direction the particular property is increasing or decreasing, this actually is most important thing. Okay, so in this particular direction the entropy is decreasing. Okay, this is the main thing why I am telling you this diagram. In this direction the entropy is decreasing, the pressure is increasing. As we are moving upwards the pressure is increasing, temperature is increasing, but the entropy is decreasing. Okay, so S3 is less than S2 is less than S1. Clear or not? Okay, similarly volume is also decreasing in this direction. As we are moving upwards this volume is also decreasing. Okay, here you can see constant volume lines in yellow, V1, V2 and V3. Okay, and such that V3 is less than V2 is less than V1. इस डायरेक्शन में वॉल्यूम डिक्रीज होगी, एंट्रोपी इस डायरेक्शन में डिक्रीज होगी, बट प्रेशर और टेम्परेचर इस डायरेक्शन में इंक्रीज हो रहा है. गेटिंग दिस, एंड दिस इज द क्रिटिकल पॉइंट. pH diagram. Clear or not? Okay, next diagram is the PV diagram, pressure volume diagram. Okay, now what is this PV diagram? This here you can see in black the saturation curve. Okay, now in this purple color you can see the constant temperature lines. Okay, constant temperature lines. Now just understand this constant temperature lines. If I am keeping the temperature constant and I am increasing and I am decreasing the volume. Okay, let's suppose here we are having the vapor phase, here we are having vapor phase, here we are having liquid plus vapor, and here pure liquid. So suppose I am having the steam vapor phase, water in the vapor phase, and I am decreasing the volume. That means if I am compressing it, let's suppose I am having the vapor in a piston cylinder arrangement. Okay, now keeping the temperature constant, I am decreasing the volume. I am continuously decreasing the volume. So what will happen? As I am decreasing the volume, as you can see, the pressure will increase initially. Okay, then after a certain point, the pressure will remain constant, and here the phase of this gas will change. That means if I am keeping the temperature constant and I am decreasing the volume, up to a certain point the pressure will increase. Then further, if I am decreasing the volume, now the phase will start changing. That means the vapor will be converted to liquid, and at this particular phase, okay, at liquid vapor phase, obviously the pressure will remain constant. The vapor is getting converted to liquid as I am decreasing the volume continuously. It is on initially when I am decreasing the volume, the pressure was increasing. Then after a certain point, after saturation pressure, obviously this further decrease in volume will change the phase. That means vapor will be converted to liquid, vapor will be converted to water. Okay, up to this particular point, here we are having pure water, complete water. not a single point of vapor here. Now further, if I want to decrease the volume, okay, you can see decreasing the volume now is a very big task. You have to increase the pressure very much. Why? Because the water is almost incompressible. Almost incompressible means if you want to compress it, you will have to apply more force, more pressure. That means for decreasing a small volume, okay, you can see here, for decreasing a small volume you have to increase a pressure sufficiently large. Just to decrease this much volume, you have to increase this much pressure. Getting this? That's why you are getting such type of curve. So here again, if I am increasing the temperature, the curve is like this. Okay, so likewise, if I am increasing the temperature, the curve is shifting towards top of this dome. And at top again we are having the critical point, and the temperature corresponding to this critical point is the critical point temperature, and the pressure corresponding to this critical point is the critical point pressure. Clear or not? Okay, so this is the PV diagram. Okay, next is the HS diagram, enthalpy entropy diagram. This actually is very important diagram because this is also called as the Mollier diagram. You can see this at the back of your steam table. If you are having the steam table, you might be using it for the university purpose. Okay, I will show you how the steam table looks like and how to study how you can find different values using the steam table and Mollier diagram. Okay, first let me tell you about this Mollier chart. Okay, this is the HS diagram. You can see the saturation curve here. This is a saturation solid line. Okay, these lines are saturated liquid lines. Okay, and this is the dry saturated vapor line. Okay, here we are having the critical point at this particular point, and this is a triple point line. Triple point, again here is a line. Okay, just to show you different properties. Okay, you can refer this diagram. Okay, now here in blue you can see this pressure, constant pressure curve. The pressure is continuously increasing in this direction. That means P3 is greater than P2 is greater than P1. First thing. Okay, in green you can see constant temperature lines. Okay, temperature is also increasing in this direction. Temperature is also increasing. That means T3 is greater than T2 is greater than T1. Okay, here in light blue you can see constant dryness fraction lines. Okay, this is the critical point. Okay, as I told you here, this is the critical point, and I am just taking this much area here. Okay, so here we are having this is a critical point, and from here we are having the constant dryness fraction line, x is equal to 0.9, 0.8 and so on, keeps on decreasing. Clear or not? And in yellow we are having constant volume lines, and again volume is decreasing in this direction. ओके, सो वेरी सिंपल टू रिमेंबर, वॉल्यूम जो है वो डिक्रीज होती है, हमने टीएस में भी देखा, पीएच में भी देखा, ऊपर की तरफ जब हम जा रहे हैं वॉल्यूम इज डिक्रीजिंग. दैट मीन्स V3 इज लेस देन V2 इज लेस देन V1. टेम्परेचर इज इंक्रीजिंग, T3 इज ग्रेटर देन T2 इज ग्रेटर देन T1, एंड प्रेशर इज ऑल्सो इंक्रीजिंग, P3 greater than P2 is greater than P1. Clear or not? Okay, and this, as I told you, is a Mollier chart, and this in fact is very useful for determining different properties at different states. Okay, now I will show you how you can determine different properties. Okay, one more thing here, before actually getting to the steam table and Mollier chart, one more thing I would like to tell you about this diagram. You can see this diagram is continuously diverging. Okay, sorry, these lines are continuously diverging. Okay, the pressure lines. Okay, here the gap is less, gap between two constant pressure lines is less, and here you can see the gap is getting more. That means this constant pressure lines is continuously diverging. Okay, now what is the reason behind it? I will show you. So as we know, what TDS is equal to DH minus VDP. Okay, we are looking at for the constant pressure. So for constant pressure, for pressure is equal to constant, obviously this TDS is equal to DH. Okay, or you can say this dH by ds is equal to T. dH by ds means the slope of which curve? Constant pressure curve, because we are having here P is equal to constant, and at this particular case when pressure is equal to constant, we are getting this slope dH by ds is equal to T. Now what does this means? This is the slope of constant pressure curve. Okay, so this dH by ds is equal to T. That means as temperature is increasing, temperature जैसे जैसे increase होगा constant pressure curve में, obviously the slope will increase, and this is the reason why this constant pressure curve is getting diverged. Okay, you can see here जैसे जैसे temperature increase हो रहा है. Okay, here we are having T1, then T2, then T3. So as the temperature is increasing in this constant pressure curve, as the temperature is increasing in this constant pressure curve, the slope will increase. Okay, or slope increase हो रहा है, then obviously this curve has to diverge. The difference between these two constant pressure curve will increase. Getting this or not? Okay, so here very important thing, the slope, the constant pressure lines are continuously diverging. Why? Because as the temperature is increasing, the slope of this constant pressure curve is getting increased. Getting this or not? Okay, now I will show you with the help of this steam table how you can determine different properties. Obviously this steam table is not allowed in GATE exam, but आपको उसके जो contents है, जो ज़रूरी contents है, वो आपको वहाँ पर दे दिए जाएंगे. Okay, so you must know how you can determine different properties with the help of steam table as well as Mollier chart. Mollier chart, however, will not be useful for you, but still you must know to have the knowledge. Okay, now the steam table, let's suppose I want to determine the properties. Okay, now just understand this thing very carefully. Let's suppose I want to at 2 bar and 200 degree centigrade. Okay, 2 bar or 200 degree centigrade mein I want to determine different properties. That means I want to determine enthalpy, entropy, specific volume and so on at 2 bar and 200 degree centigrade. Okay, you might be knowing this thing from your university point of view, you might have studied. Okay, but still I will tell you. Okay, so 2 bar and 200 degree centigrade. So how you can see this steam table? This is the steam table of RS Khurmi. Okay, RS Khurmi steam table, and I will explain you with the help of this steam table only. So you can see here the very first table is of temperature, and corresponding pressure is given in this table number 1. Okay, this is the table number 1. The temperature is given and the corresponding saturation pressure is given. You can see here, and again we are having this table number 2. Okay, where I am having certain pressure और उसके corresponding saturation temperature दिया है. Okay, so I will use this table. Okay, that means the pressure is given and corresponding to that pressure what will be the saturation temperature. Okay, so as you can see here at 1.01325 bar, the saturation temperature as we know is 100 degree centigrade. Getting this point or not? Okay, at 1 atmosphere pressure पे saturation temperature जो है that is 100 degree centigrade, and as I am increasing the pressure, you can see the saturation temperature is also increased. So at 2 bar, now just look at here carefully. At 2 bar, the saturation temperature is 120.2 degree centigrade saturation temperature, and we have got the condition at 2 bar and 200 degree centigrade. So let us first determine the state of this steam. What will be the state of this steam? So if I draw this TS diagram, obviously इसमें अगर मुझे locate करना है इस particular point को 2 bar और 200 degree centigrade को, so where will be it located? So this pressure is, let's suppose, 2 bar, and saturation temperature as I told you is around 120 degree centigrade. Okay, saturation temperature means this temperature is 120 degree centigrade. If I want to locate this 200 degree centigrade at this 2 bar, obviously it will be somewhere here. That means it is a superheated steam. Okay, and for determining the properties of superheated steam, we are having this superheated table here. Okay, at last of this steam table you can see the superheated table. Okay, okay, so here in page number 18 in this RS Khurmi book, we are having a specific enthalpy of superheated steam. Okay, here we are having a specific volume of superheated steam. So if your steam is superheated, then obviously you can jump directly to the superheated table. So if I want to determine the enthalpy at this particular point, okay, now what will be the enthalpy at 2 bar and 200 degree centigrade. So here we are having 2 bar and here it is 200 degree centigrade. So at this particular point the enthalpy you can see is 2870.5 kilojoule per kg. Okay, so at 2 bar and 200 degree centigrade the enthalpy is 2870.5 kilojoule per kg. So this is how you can determine the enthalpy in different properties at any particular point. Similarly, if you want to see the entropy at this point, so what will be the entropy here? So you can see here, here you are having specific entropy table, a specific entropy of superheated steam. Okay, so at 2 bar and 200 degree centigrade, at 2 bar and 200 degree centigrade, the specific entropy is 7.507 kilojoule per kg Kelvin. Okay, so at this particular point the specific entropy S is equal to 7.507 kilojoule per kg Kelvin. Getting this or not? Okay. Now if it is asked कि अगर मान लो कि बात ये पूछा जाता है that you want to determine this enthalpy and entropy at 2 bar and 175 degree centigrade or 170 degree centigrade. Okay, so you can what you can do here is, क्योंकि अब यहाँ पर क्या दिया हुआ है, एक तो 150 पे दिया है, okay, entropy is given at 150 degree centigrade and 200 degree centigrade. So in between अगर किसी point पे if you want to determine, you will have to interpolate. Okay, interpolation आप लोग जानते होंगे how we can do interpolation. So you can see here the pressure at 2 bar. Okay, you can write the temperature here at 150 degree centigrade. The entropy is 7.2799 kilojoule per kg Kelvin, and at 200 degree centigrade the entropy is 7.507 kilojoule per kg Kelvin. Okay, so at 170 degree centigrade if you want to determine the entropy, let's suppose that is S. Okay, so interpolation का formula हम सब जानते हैं, that is what, y minus y1 is equal to y2 minus y1 upon x2 minus x1 into x minus x1. Okay, so this is the formula for interpolation. Now here you can take this as y1, this is y2 and this is y which you want to determine. Here this is x1, this is x2 and this is x. Okay, so with the help of this formula at 170 degree centigrade or at any temperature in between two temperatures you can determine very easily. Okay, I am not getting into much details, I am just telling you the overview because you might be doing this in your university exams, I know. Getting this or not? This is how you can determine certain properties with the help of this steam table. Same thing if you want to determine with the help of Mollier chart. Let's suppose if it is asked that at 2 bar and if the dryness fraction is given as, let's suppose, 0.7. Okay, so at 2 bar you have got different properties, you have got HF, HFG, VF, VFG. So just take the table. Same thing. At 2 bar you have got the value of this HF, you have got HF, you have got HFG, and you know that H of wet steam is HF plus X HFG. So from here you can determine the properties of this wet steam. Getting this or not? Okay, so wet steam obviously will be somewhere here or in this particular region. Clear or not? Okay. Now why am I telling you all these things? Because I wanted to explain you the Mollier chart. Okay, so I will now show you the Mollier chart. This Mollier chart also you are having at the back of your steam table. I think पूरा ये एक साथ स्क्रीन में नहीं आ पाएगा, but I will try to explain you this whatever portion comes here. Okay, so here you can see this Mollier chart and this is nothing but HS diagram. ये आपका HS diagram ही है जो मैंने just now आपको explain किया है. Okay, so here you can see this HS diagram और यही HS diagram है, इसको इस Mollier chart में यहाँ से लिया गया है from here. Okay, you can not even see the critical point here. Okay, so this is our saturation curve. Here you can see this, the dark line is the saturation curve line, this line. Getting this or not? Okay, now you have got different pressure lines, different temperature lines. You can see here different pressure line. Here this is 0.01 bar, 0.01 bar, this is constant pressure lines, then 0.02 bar, 0.03 bar and so on. So as you are getting upwards, as I told you, the pressure is continuously increasing, the pressure is increasing, first thing. Second, the temperature line, constant temperature line. So these are constant temperature lines, you can see here 50 degree centigrade, then we have 100 degree centigrade, then we have 150 degree centigrade and so on. Okay, so these are different pressure, constant pressure lines and constant temperature lines. This is actually enthalpy entropy diagram. Okay, at any, if you can locate any point, then corresponding to that point you can if you project it in y axis you will get the specific enthalpy at that point. If you project it in x axis you will get a specific entropy at that particular point. Okay, I will give you one example. Same example we will consider because we have already determined with the help of the steam table, और उसी को हम वापस कंसिडर करते हैं. At 2 bar and 200 degree centigrade, at 2 bar and 200 degree centigrade, same thing. Where is 2 bar? So here you can see this is constant pressure lines at 2 bar, that means this line, this particular line. Okay, I hope you can see this. This is the constant pressure line 2 bar, and then here we are having constant temperature line 200 degree centigrade. Okay, so this is 2 bar and 200 degree centigrade. It will meet somewhere here. Okay, दोनों का meeting point देख लो, this point. Getting this now? Okay, so if I am projecting this point to the y axis, I will get the value of specific enthalpy. Okay, how? This is 2 bar and 200 degree centigrade, this point now. Okay, so if I am projecting this in y axis, this is the point, getting this? That means this is 2800 kilojoule per kg, then 1 2 3 4 5 6 and 7th point, that means 2800 plus 70, 2870. Okay, obviously you will not get very exact figure here, but an approximate idea you can get and very fast you can get. Just you have to locate the point. जितना time आपको उसमें लगता है steam table में, उतना time इसमें नहीं लगता है. Simply you can determine directly. So here you can see 2870.5 and here also we got the same value 2870 kilojoule per kg. Similarly, if you want to determine the specific entropy at this particular point, the specific entropy you can project it on x axis and you can determine the specific entropy and so on. Okay. Similarly, if you are having suppose the wet steam at, let's suppose 2 bar and 0.7 dryness fraction, as we have seen the example. So at 2 bar here you can see these lines are the constant dryness fraction line. You can see x is equal to 0.95, 0.9, 0.85, 0.8. Okay. So at 2 bar and 0.7 dryness fraction. So this is the line for 0.7 dryness fraction and this is the line for 2 bar. Okay. So you can locate the point, and once you have located the point, then it's not a very big deal to here. Okay. So corresponding to this, if you project it on y axis, you will get a specific enthalpy. If you project it on x axis, you will get a specific entropy. Okay. So this is how you can use this Mollier diagram to determine different properties of the water at different states, different phases. Clear or not?